Okay, we are on page 15 and looking at arithmetic sequences. And so just kind of taking a step back as to what's coming ahead, we're going to be looking at a variety of sequences as well as series. And how do we differentiate the two is sequences are a list, whereas series are a sum. And so when we have different types of sequences and series based on the patterns that they make. So today we're going to start looking at arithmetic sequences. So a list of particular numbers that follow a particular type of pattern. So specifically an arithmetic sequence is a sequence, a list in which each term can be found by adding something to the previous term. And we can be adding a negative as well as a positive. So if you see things going down, it's not that, don't think of it as you're subtracting, rather think that you're adding a negative. So if we take a look at the sequence 7, 10, 13, 16, we can see pretty clearly that we can find the next term by adding 3 to it. So adding 3, so that's where we fill in that blank. And so calculate the differences. This notation using a subscript, we would call that term 2 minus term 1. So take a look at what numbers are in which order. So the second term is 10. And minus the first term, T1 is 7, and that equals 3. Term 3 is 13, minus the second term, 10, and that is, of course, also 3. Term 4, which is 16, minus term 3, 13, is also 3. And so that is called our common difference, and we're going to use the variable d to show that. So the common difference in this example is 3. So finding the common difference, we can subtract then any term from the previous term, the term after it. Okay, so term 2 minus term 1 is our common difference, or term 5 minus term 4. In this particular notation, so d is equal to, our common difference is equal to, take any term and take away, well, how do I do the term before? So this is the same term, the term before it is n minus 1. So tn minus tn minus 1. That would be our common difference. Okay, so if we take a look at class example number 1, the sequence 16, 13, 10, 7, our common difference, we can see it's going down, so we know the common difference is negative. Again, if you wanted to calculate it out, difference is term 2 minus term 1, or also term 3 minus term 2. Either way we look at it, 13 minus 16, or 10 minus 13, or 7 minus 10, the common difference is negative 3. Okay, so that is how we can tell if we have an arithmetic sequence, is because there will be a common difference. If there is no common difference, it is not arithmetic. Okay, so take a moment, hit pause, and fill in the answers for class example number 2. Okay, so if we take a look at the first one, we have 2, 4, 6, 8 are even numbers, and that is, of course, arithmetic, because every time we have a common difference of 2 that we are adding to each time. For B, it is not arithmetic, because the difference between 1/2 and 1/4 is not the same as the difference between 1/4 and 1/8. For C, it is once again arithmetic, and our common difference is 6, because it's going up by 6 each time. And for D, it is once again not arithmetic, because there is no common difference. Okay, so some of the terms that you've heard me say already, but just to emphasize, so our first term, we can use T1 for term 1, or sometimes they'll also use the variable A, and the common difference, of course, is represented by the variable D. And so if you take a look at your formula sheets, you will see different versions, some using T1, others using A, and D, of course, comes up as our common difference. Okay, so once again, let's take a look at class example number 3. You can go ahead and hit pause and complete those. So in our first one, we have our term 1, or A, is -8, and it's increasing by 10, so the common difference is 10. In the second one, our first term, T1, or A, is 15, and it's going down by 5. So we're going to say that the common difference is -5, showing that it's going down. And you can always confirm that, of course, by doing term 2 minus term 1, which is also 10 minus 15, which is -5. Okay, let's take a look at this little investigation. So this is what we're going to use to develop the general term of an arithmetic sequence. So if we take a look at the arithmetic sequence of 2, 12, 22, 32, 42. So with this terminology, we have essentially T1, term 1. So that what is in the first place is 2, term 2 is 12, of course, term 3 in the third spot is 22, term 4 is 32, term 5 is 42, and A, which is the same as T1, is once again 2, and our common difference, we are adding 10 each time. So take a look at the pattern. So once again, I'm just going to hit pause and allow you time to fill those out, and then we'll reconvene and talk about those. Okay, so if we take a look at that first column, then term 1 we know is 2. Term 2, we know that we can find that because we're taking 2 and we're adding 10 to it. So that's why it's 12. Term 3 is going to be 2 and then plus 10 to get to our second term, and then plus another 10 to get to the third term. And so that's why we're looking at 2 plus 2 tens, or plus 20, is 22. Term 4 is going to be the first term, plus 10 to get to our second term, plus another 10 to get to our third term, and plus another 10 to get to our fourth term. So then that is 2 plus 3 times 10, or 32. And so we can continue that pattern, and how many tens, how many differences are we adding? And it's always one less than the term number, which is why for term 30, 2 plus 29 times 10, or 292. So to generalize it for this particular sequence, we would have 2 plus n minus 1. So depending on what term we're looking at, term number, it's 1 less than that, and then times the common difference. So in this particular case, that would be 10. And so the one thing that I will ask that you do, if you're writing a general term for a particular sequence, please distribute and clean that up. So we've got 2 plus 10n minus 10, or 10n minus 8. And this is what we would call the general term sequence for this particular scenario of 2, 12, 22, 32, etc. Okay, to generalize that, rather than 2, it's going to be any first term. So term 1 is A, term 2, you're going to have your first term A plus 1 difference. Term 3 will be A, your first term, plus the difference twice, and so on. So then it's always going to be 1 less than your common difference then. Okay, multiplied by your common difference. So these formulas are on your formula sheet, and they're basically the same thing depending on whether or not you want to use T1 or whether or not you want to use A. And so we know the variables A and D, the two new ones that are kind of introduced here, N being the position of the term in the sequence. So if you think about a number of numbers standing in line or filling in the blanks, then, so which blank does it hold? So 32, this is in the fourth spot, so that would be the fourth spot, so n is equal to 4. 32 represents the value of the term in the fourth spot. So Tn is the general term of the arithmetic sequence, or T4 is the term value. Okay, let's take a look then. So in this particular case, class example number 4, consider the arithmetic sequence and determine the formula for the general term of the sequence. So what is it that we're looking for is we want to use the formula Tn is equal to a plus n minus 1 times d, but we're going to make it specific for this sequence. So what do we know about this particular sequence? Is our first term is -6, and our common difference is 5. So we can substitute those in then. So Tn is equal to -6 plus n minus 1 times 5, and we'll distribute the 5 and clean it up. So Tn is equal to -6 plus 5n minus 5, or Tn is equal to 5n minus 11. This general term formula then is specific to our sequence, and that means that if I'm looking for the value of the 12th term of the sequence, I don't have to go back to Tn is equal to a plus n minus 1d. I can actually just substitute it into the Tn formula. So Tn is equal to 5n minus 11, so I want term 12, so 5 times 12 minus 11, or 60 minus 11, is equal to 49. So the value of the 12th term is 49. Okay, let's take a look at class example number 5. The number of terms in the arithmetic sequence: 3, -1, -5, and at the end, -117. So again, we know that we're going to use this formula because it is an arithmetic sequence. What have we been told? We know that 3 is our a value. A is equal to 3. Our common difference, it's going down by 4, so we have a common difference of -4. And now I need to fill in either for Tn or n. Because the question asks us, find how many terms there are, that means that we don't know n. But what we do know is that last value, which is -117. So for example, if you imagine, if we knew that there were 30 terms in the sequence, then -117 would be term 30. But we don't know how many terms, that's why we're calling it n and Tn. So let's fill in for our variables. Just like in physics, you're always going to start with your formula, write down what you know, and then substitute everything in, and then solve your equation. So if I write it like this, I've actually made a mistake. Because if you think about it, d, we're multiplying n minus 1 times d, but by filling in -4, it makes it look like I'm subtracting 4. So if I want to multiply, then I need to put some parentheses around the -4, or else you could also move the -4 to the front of the n minus 1 to be able to distribute that. Okay, so let's clean this up then. I'll subtract 3 from each side, so -120 is equal to -4n plus 4, distributing that. -4, subtract 4 from each side, -124 is equal to -4n. Divide both sides by -4, and n is equal to 31. So that tells us that there are 31 terms. So please take a moment and just answer the question. Find the number of terms. There are 31 terms. And I want to also just take a moment and ask you to think about what values for n would be impossible. So at some point you need to say to yourself, hey, I've solved this equation. Wait a second, that answer doesn't seem correct. Well, what does n represent? It's the number of terms. So we can't have a decimal or a fraction. I can't have term number 3/4. We also can't have a negative term number. So n has to be an element or belong to the set of natural numbers, because again, we shouldn't have term 0, but we'll talk about that as a possibility as well later on down the road. Technically speaking, our first term is term 1, not term 0. Okay? So let's take a look at arithmetic means, and there's a few different ways to solve arithmetic means problems, but let's take a look at what arithmetic means are first off. So arithmetic means refer to terms placed between two non-consecutive terms of an arithmetic sequence, and that is what is arithmetic means referring to. So for example, I think of it as fill in the blanks. So if it says place 3 arithmetic means between -4 and 8, I think to myself -4, and there's 3 fill in the blanks and followed by 8. So because it's arithmetic means, I know that I'm going to have an arithmetic sequence, and there's lots of ways to go through this. Some people can figure this out logically, other people might use guess and check. Please don't use guess and check because it might not always work out nicely, and that could also take you more time. But how do we actually figure this out algebraically is we don't know -4 if it's in what position, but we can temporarily or hypothetically say, hey, what if this was my first term? Then we would know that this is going to be term 2, this is term 3, this is term 4, and 8 would then be term 5. Because we have that information, we can then go back to our general term formula, which is Tn is equal to a plus n minus 1 times d, and substitute in what we know. Well, term 5, if we said term 5 is equal to a or -4 plus 5 minus 1 times d, well, term 5 is 8, so we'll put that in, -4 plus 5 minus 1, so 4d, and there we've got a simple little equation to solve. Add 4 to each side, so we've got 12 is equal to 4d, so d is equal to 3. So if our common difference is 3, I can go ahead and add 3 to -4. That makes -1. Add 3 again, so that will be 2. Add 3 is 5, and sure enough, when we add 3, we get 8. So yes, there are a number of different ways to go through this. This is just one way that we can figure that out. Okay. Let's take a look at this problem. So we have a sequence, and we've got some variables in there, x plus 2, 3x minus 1, and 2x plus 1. So let's determine the value of x such that x plus 2, 3x minus 1, and 2x plus 1 form an arithmetic sequence. So what do we know that's going to be key? What makes up an arithmetic sequence is the fact that there is a common difference. So we don't know the common difference, but we do know that you could find the common difference by doing term 2 minus term 1, and that should be the same as term 3 minus term 2. And since we have that, we can go ahead and substitute those expressions in to build our equation. So why don't you go ahead and hit pause and try that question out and complete parts A and B. And by doing B, it will confirm whether or not you have the correct x value. Okay, so forming that equation, the trickiest part is, of course, because you're subtracting a binomial, you're subtracting x plus 2, or you're subtracting 3x minus 1, so you need to remember to distribute that negative. And then at the end of the day, we end up with x is equal to 5/3. So I know the first time that I tried this problem myself, I thought, uh-oh, I don't know if I've done something right or wrong. And then the only way to know for sure is to substitute 5/3 back into those algebraic expressions and to see what we end up with. And so for part B, we substitute 5/3 back in. Of course, we need a common denominator in many cases to add those together. Please do not change it into a decimal. So term 1 is 11/3, term 2 is 4, term 3 is 13/3. It might not be as obvious that you have an arithmetic sequence until you change 4 into thirds as well. And 4 is, of course, 12/3. So now it becomes more obvious. Term 1 is 11/3, term 2 is 12/3, and term 3 is 13/3. And that is, of course, an arithmetic sequence then, 11/3, 12/3, 13/3. And so our common difference would be 1/3. Okay, so class example number 8. So there are a number of ways to go through this particular problem. And again, I'm not going to be specific about which method that you decide to use. My thought is that please try to stay away from guess and check. Rather, you should be using some kind of an algebraic means or some type of a formula. And yes, there are formulas to go through this. So options. The two key options that I would say would be to use an arithmetic means and also to do it using a system of equations. So we're going to use arithmetic means. What I would actually do is say, map this out. For a lot of people, it works out well to think about it as fill in the blanks. So the third term is 12. That means I don't know my first two terms, and then that's term 3, 4, 5, 6, 7, and then the 8th term is negative 18. So if I'm using arithmetic means, I need to hypothetically put this at term 1. Okay, so if this is temporarily term 1, then this is term 2, term 3, term 4, term 5. This is going to be my term 6. And then we're going to treat this very similar to the first arithmetic means question that we did. Was we can say, okay, Tn is equal to a plus n minus 1 times d. And so negative 18 is term 6. 12 is term 1, and so since it's term 6, n is 6, so that would be 6 minus 1, or 5d, and a very simple linear equation to solve. Subtract 12 from both sides, so that's negative 30 is equal to 5d, so then divide by 5, and d is equal to negative 6. At that point, I can fill in from what we know. So if we know 12, and that means that this is going to be 18, that will be 24, and then we're looking at 6, 0, negative 6, and negative 12 then, and so that seems to work out nicely in that case. The other option is to, oh, sorry, I should answer the question. Determine the 5th term of the sequence. So I can't use my temporary term 5. I need to say, okay, remember, this is actually term 3, term 4, and term 5. So the actual term 5 is 0 then. Okay, so the other way to go through this is to use a system of equations where we know term 3 is equal to 12 and term 8 is equal to negative 18. Once again, using that Tn is equal to a plus n minus 1 times d. For the first one, we can say 12 is equal to, we don't know a, n in that case is 3, so 3 minus 1 is 2, and we don't know d, so there's our first equation. The second equation, term 8 is negative 18, we don't know a, n is term 8 for term 8, so 8 minus 1 is 7d, and now we have a system of two equations, two unknowns, and that should be pretty straightforward then for you to solve. So I'm going to hit pause and go through, and you can solve, try that out, and then we can compare. Okay, so I decided that I was going to subtract equation 1 minus equation 2, so subtracting 12 minus negative 18 is 30, a minus a is of course 0, 2d minus 7d is negative 5d, divide by negative 5, and d, our common difference is negative 6, which we had earlier found, and then we can substitute it into either equations 1 or 2 to figure out what our a value is. Okay, so I'm not going to go through this other method that they talk through, but that's the other option, and that is what we've done, and so we're ready for the assignment. So please go ahead and check ManageBac for those assigned questions, and let me know if you have any questions.